Hello, class. Today we're going to discuss different methods of how objects become charged. Now, suppose we have two metal spheres, one positively charged and the other neutral. If we were to place a metal sphere, or a metal object, say a nail, touching both spheres, the previously uncharged sphere quickly becomes charged. Now, instead of a nail, if we have a piece of wood touching both spheres, the uncharged sphere does not change. Materials like nail or any piece of metal are said to be conductors, whereas materials like a piece of wood or rubber or plastic are said to be insulators or non-conductors. From the atomic point of view, electrons in an insulator are tightly bound to the nuclei, whereas the electrons in a conductor are loosely bounded to the nuclei and can move freely around the metal material. These electrons are often referred to as free electrons. The first way a charged object can be charged is by conduction, or touching a neutral piece of metal to a charged object. Now, suppose a positively charged metal object A touches an uncharged metal object B. The free electrons and the neutral ones are attracted to the positively charged object, and some of those electrons will pass over to it. Since object B is now missing some of its negative electrons, it will have a net positive charge. This process is called charging by conduction, or by contact, and the two objects end up with the same sign of charge. Now, suppose a positively charged object is brought close to a neutral metal rod, but it does not touch it. Although the free electrons of the metal rods do not leave the rod, they still move within the metal towards the external positive charge rod, leaving the positive charge at the opposite end of the rod. A charge is said to be induced at the two ends of the metal rod, though no net charge has been created in the rod. Charges are merely just separated. The net charge on the metal rod is still zero. However, if the metal is chopped in half while the positive rod is close and not touching, one piece would be positively charged and the other piece would be negatively charged. This is called charging by induction. Another way to induce a net charge on a metal object is to first connect it with a conductor wire to the ground. Now, the symbol with the three lines means it's connected to the ground. The object is then said to be grounded. The Earth, because it's so large and can conduct, easily accepts or gives up the electrons. Hence, it kind of acts like a reservoir for charges. Now, if a charged object, say negative this time, is brought close to the metal object, free electrons in the metal are repelled and many of them move down the wire into the Earth. This leaves the metal positively charged. Now, if the wire is cut from the ground while the charged object is still near, the metal object will have a positively induced charge on it. Now, charge separation can also be done in non-conductors or insulators. If you bring a positively charged object close to a neutral insulator, almost no electrons can move about freely, but they can move slightly within their own atom or molecule. So each oval represents a molecule. The negatively charged electrons are attracted to the external positive charge. Then it moves in the direction within their molecule. Because the negative charge and the insulator are near to the external positive charge, the insulator as a whole is attracted to the external positive charge. It's the same as rubbing a rubber balloon and having the charged balloon stick to an insulating wall. Now, an electroscope is a device that can be used for detecting charges. Inside a case are two movable metal leaves, often made of gold foil, connected to a metal knob on the outside. If a positively charged object is brought close to the knob, a separation of charge is induced. The electrons are attracted up the knob, and the leaves become positively charged. The two leaves repel each other because they're both positively charged. If instead the knob is charged by conduction, meaning touching, the whole apparatus becomes a net positive charge. In either case, the greater amount of charge, the greater amount of separation of the leaves. Now, notice that you can't really tell the sign of the charge in this way, since negative charge will cause the leaves to separate just as much as an equal amount of positive charge. An electric scope can, however, be used to determine the sign of a charge if it's first charged by conduction. Let's say negatively. So now, if a negative object is brought close, more electrons are induced to move down into the leaves and they separate further. However, if a positive charge is brought close instead, the electrons are induced to flow upward, so the leaves are less negative and their separation is reduced.